Hello and welcome to my video. My name is Eliana and today we're gonna see language processing in the brain and so briefly explore the structures and functions of language areas. Let's think of language as this super cool toolkit we use every day to talk, sign, and write messages. It's how we communicate ideas, show who we are, play with words, imagine, and let our emotions out. But it's not just about words. Language works in cultural and social settings. When we talk, our brain is juggling a bunch of tasks at once, moving our mouth to speak, making sounds that make sense, and putting words together into sentences that don't sound weird. On the flip side, when we hear someone, our brain breaks down all the sounds, grammar, and meaning at the same time. But before we move on, I want to briefly focus on what syntax and what semantics is. Since we do not only communicate with ourselves, we need fixed structures to help us understand each other. We can think of syntax as a set of rules for arranging words in a sentence. Let's take these three words. John eats pizza. So a correct syntax follows a proper word order. In this case, in English, it would be subject, verb, object. An incorrect syntax would be John pizza eats. Since this breaks English grammar rules, it sounds awkward and confusing because the words are out of order, even though you recognize the same words. Semantics is all about meaning, what the words and sentences are actually trying to say. This is why the dog chased the cat means something totally different from the cat chased the dog. Now that we got an overview of what language allows us to do, let's move on. How does your brain pull this off? We're gonna see step by step what language processing is. So, your brain is like a high-tech language processing center with different areas doing different jobs. First of all, we have sound check. First, sound goes through your ears to a part of the brain called the primary auditory cortex. Here, once the sound reaches this area, our brain has to figure out is this speech or just background noise. This happens in areas like the plano temporale and generally in the superior temporal gyrus, this green area here. Step 2 will be building sentences, or if we're hearing, understanding sentences. Here's where your brain starts recognizing word types like noun, verbs, and organizing them into a sentence. It's a team effort from areas like Broca's area and the frontal operculum FOP, which handle how words fit together. Step 3 would be figuring out which meaning the words have, so semantics. Your brain decodes what the words and phrases mean using the anterior temporal lobe and the middle temporal gyrus. This part is crucial for understanding relationship between words, like who's doing what to whom in a sentence. Step 4, we have to put all this information together, integrate, and really understand what's going on. We combine the grammar and the meaning into something that makes sense. This happens in the inferior frontal gyrus and the posterior temporal cortex. Additionally, while we speak or listen, our premotor cortex is on standby to help us map sounds to movements so we can speak clearly. That is, it helps us to articulate. But how do all these areas interact? Well, there are various theories for that, but the one that gained most neuroscientific backup is the dual pathway model. So let's think of our brain's language system like having two highways: the dorsal highway that handles grammar and syntax, and the ventral highway that connects sound to meanings. Now, during the mid 19th century, scientists were pretty sure that the left hemisphere did all the work. This is because of various findings with lesion patients, where lesion of areas in the left hemisphere led to significant language impairments. These important discoveries also led to the naming of areas like Broca's area and Wernicke's area. But in the 20th century, ideas started to change, with findings using split brain studies and neuroimaging techniques to strict left lateralization to the idea that for most right-handed individuals, the left hemisphere of our brain still plays a big role in our processing, at least for functions like syntax and digital semantic processing. However, it's not that strict anymore, and we have seen that both hemispheres work in language processing. Well, we almost came to the end of this presentation, and let's talk about the fact that language processing is also influenced and influencing non-language regions. Language processing is not a closed circuit. Your brain doesn't just process words in isolation. It pulls in help from areas that handle memory, emotions, and this is helpful for social interactions to add context and understand tone. And this is why we can pick up sarcasm or understand someone else's feelings just from the way they say something. The brain structures that are involved in emotional speech are the same as for language processing with some additions. We might have areas like the superior temporal gyrus and superior temporal sulcus that in this case elaborate emotional prosody and recognize emotional tone in voices, or the inferior frontal gyrus, which we also saw before, that helps decide how important the emotion is. But we also have some, let's say, new areas involved, like the amygdala. They can spot emotional signals quickly, detecting anger or happiness in voice, understanding emotional tones, and blend them with a message. Language areas have to be able to handle working memory. For example, Broca's area is heavily involved in syntax and working memory. So it handles complex sentences, and the more they are complex, the harder this area works, so that we can keep sounds and words in our head while we figure out what to say next. So, this was everything from me. I hope you got an overview of how language processing in the brain works, and that this may have sparked some curiosity about language and its cool words.